So let's pick up here. We were talking about equilibrium constants and equilibria in equations, chemical equations. So here we have an example of an equilibrium reaction. The double-headed arrow means that the reaction goes in both ways. KEQ is the equilibrium constant. It says at 1,000 degrees because the equilibrium constant is going to change depending on what the temperature is. And so the temperature is often specified, but that temperature doesn't get used in a calculation. That's saying, okay, this is the temperature we're talking about, and here's the equilibrium constant. And so we did how to calculate an equilibrium constant, and this is using a constant in a calculation. So here's the equilibrium expression. It's the concentrations of the products divided by the concentrations of the reactants. And if there's a coefficient in the balanced chemical equation, then the concentration of that reactant is raised to that power. So 2 COF2 means we take the concentration of COF2 and we square it. So in this question, they're giving us 2 of the 3 concentrations. They're giving us the equilibrium constant, and they're asking us to find the other concentration. Because this expression here has 1, 2, 3, 4 variables. If they give us 3, we can find the 4th no matter what it is. So what they're doing here is they're just rearranging the equation to solve for the thing we're interested in. You plug the numbers in, and you get an answer. There are no units on the equilibrium constant, but it is understood that all of the concentrations are in a unit called molarity, moles per liter. We haven't studied that yet, but that's okay. Just write a capital M after your answer for a concentration. So let's do an example. So diatomic iodine decomposes at high temperature to form iodine atoms according to this reaction, and it gives us the equilibrium constant. In an equilibrium mixture, the concentration of iodine is 0.10 molar. What's the equilibrium concentration of the iodine atoms? So let's identify the things that we've been given. So we've got KEQ up here. So I personally don't see the need to write that down again since I'm writing on the slide, but you might want to write that down. And then this number here, that is the concentration of I2 is equal to 0.10 capital M. And they're wanting us to find the concentration of I. So let's write the equilibrium expression. KEQ equals the concentrations of the products. Here there's just one, it's I, raised to a power that is equal to their coefficient, divided by the concentration of the reactants. This is a simple equation. There's one reactant and one product. So we know what KEQ is and we know what I2 is. We need to find what I is. So I didn't really think ahead. What we need to do is we need to multiply both sides by the denominator here so that we can get rid of the fraction. You could also think of cross-multiplying. Let's think of it that way. You say, well, there's not a fraction on the left side. Well, that's KEQ over 1. So if we cross-multiply, we end up with I squared being equal to KEQ times the concentration of I2. How do we find the concentration of I, though? This gives us I squared. We have to take the square root of that. Let's put the numbers in and deal with the square root separately. So KEQ is 0.011 and I2 is 0.10. And when we multiply those, 0.011 times 0.1, we get that I squared equals, I'm just going to get rid of that copyright thing down there. Isn't that fun? I squared equals 0.0011. So then we have to take the square root of that. You should have a square root button on your calculator. Just push that. And so the concentration of I should equal 0.033. And then we just understand that the unit is moles per liter. And so that's our answer down here in the corner. Any questions? You have to understand how to write the equilibrium expression from the balanced chemical equation. Products over reactants raised to the powers of their coefficients. Then look at the information that you're given. Sometimes they ask you for KEQ. They give you all the concentrations. Then you just plug the numbers in and do the math. If they're asking you for a concentration, then you have to rearrange the equation and then plug the numbers in and do the math. But if you don't understand how to do the expression, this part right here, then you're pretty much sunk. Okay, that's critical right there. Any questions?